Hello everybody, we're going to do number 10 on the study guide. This is the proof by math induction. It's pretty much math induction day 1, day 2, and day 3 all together. Alright, so this is the full proof. So the first step is to plug in n equals 1. You have to show that it's true for n equals 1. So that's the induction step. It's the easy part. You just plug in the first number. So it's going to be 1 to the third power. And on this side, you're going to plug in n equals 1. Okay. So on this side, we just have 1 to the third power. And on this side, you plugged in n equals 1. So we're just showing that it's true for the first number. All right, so what does this equal? So this is going to equal 1, and over here it's going to equal 4 divided by 4, which is also equal to 1. So it's true for the first number. Okay, so once you've done the first induction step, you tested the first number, now we move on to the second part, which is the actual proof. So to start the proof, you have to assume that it's true for n equals k, and prove that it's true for the next number, k plus 1. So remember, it's like a row of dominoes. You know it's true for 1. If it's true for the next one, then it's going to be true for all of the numbers. All right, so we're going to start by writing down the original sequence. But instead of using n, we're going to use k. We're going to assume that it's true for the kth term. And then after the kth term, we're going to write down what comes after the kth term. The next term is k plus 1. So it's just like you're adding one more to the sequence, the next number. And on the other side, you have to plug in k plus 1. Okay, so it's going to be k plus 1 here, plus 1. So I'm going to plug in k plus 1 plus 1 squared divided by 4. Okay. So this is my statement that I have, and I'm going to plug in for the first part here from 1 cubed all the way to k cubed. I'm going to plug in what's given. I know, and I'm actually going to just point up here. I'm given that this is true for the kth term. So 1 cubed plus 2 cubed. I know that that for the kth term is equal to k squared, k plus 1 squared over 4. So I'm going to plug this in for the sequence here. So I'm going to plug in k squared, k plus 1 squared over 4, because I'm assuming that this is true for the kth term. So I can plug this in for the sequence. And then I'm going to bring down the next term. Okay, so on this side, I'm just going to bring this down. Okay, so once you've plugged that in, now in order to prove it, you just have to show that both of these are true, that both of these are the same. So if you could show that the right-hand side and the left-hand side are the same, then you've showed that it's true for the k plus 1 term. So the actual hard part is to try to make these two be the same. So show that it's an identity. All right, so let's see. Let's get a common denominator. So we're going to multiply I'm going to multiply by 4 there on the top and bottom to make this a common denominator. And then I'm going to bring these down. Got. Okay, and since all of these have the same denominator, you can actually do something tricky here. You can distribute a 4 to both sides. So if I multiply this side by 4, can't see that. If I multiply this side by 4, then I could cancel that out. And if I multiply this side by 4, I actually have to multiply it to both of these. I can also cancel out the 4s. So those 4s I can cancel out but just by multiplying a 4 on both sides. Okay, so now I'm left with how do I show that both of these are the same? We could multiply this whole thing out and multiply this whole thing out, and they're going to be the same. But that's a lot of work to FOIL it out. So I think it would be easier to factor it. So I'm going to factor out the common term. So both of these have something that's the same. So I'm going to take out the k plus 1. And I'm going to take out the k plus 1 because it's like the GCF, what they have in common. Now I'm going to take out 2 because it's to the second power. So if I take out the common term, I'm going to bring this down because I'm left with k squared. Now here, what happens if I take out k plus 1 to the second power? Then I'm left with 1 factor. Because I'm going to pull out the GCF, which is 2, so I'm going to be left with 1, k plus 1. Okay, so this is factoring by grouping. It's just like removing the greatest common factor. What they both have, that's the same. And then bringing this down. So I brought this one down, and I brought this one down to the first power. Okay, so now let's look at the other side. And can I show that these two are the same? At this point, I think I'm going to have to go ahead and multiply it out. So let's distribute that. Have these parentheses now. And then I have the k plus 1 on the outside. So on this side, I'm going to bring this down. And if I multiply this out, if I write this out, that is going to equal k squared plus 4k plus 4. So you end up with the same thing on both sides. So once you've shown that it's the same on both sides, then you've shown that this is true for the next term. Okay, so if it's true for k, then it's also always going to be true for the next term. And since we know that it's true for at least one, then it's like you knock down your row of dominoes, so it's going to be true for every number. All right, that's your proof by math induction.